Well, I guess you guys all know what we're here for. It's a conversation about how you can scale your Angular applications for production or just to make your code look more like a professional developer. If you're a React or Vue developer, that's fine. Maybe I'll convince you to try Angular, and if not, maybe you'll appreciate DJ Khaled gifts. So, hello everyone. Um, my name is Michael Salati. I am primarily an Angular developer, originally from Connecticut, moving to the San Francisco area, and I've been working with Angular since the early stages of Angular version 2. And when I say the early stages, I mean like when I was in beta, and that was my first experience with Angular. I had a little taste of Angular JS, and I hated it. Uh, and nothing I really learned from that experience using AngularJS prepared me for what I needed to know to develop Angular applications. Besides, uh, besides my love for Angular, my second favorite tech is anything related to geo. I'm actively maintaining a library for doing geo queries on Firebase's Firestore, which I call Geo Firestore. So if you have any experience with GeoFire, Firebase, Firestore, I invite you guys to check that out. Besides that, I am currently working on my dream side project, which is a MAS product. If you guys aren't familiar with what MAS stands for, it's Memes as a Service. Uh, the end goal is for meme delivery by mail. So I've been saying that I'll have it done by the end of the year. As of right now, I will see if I get to it by the end of the year. And finally, I have made a lot of mistakes, and I mean a lot. So I'm hoping that maybe I can share some of the things that I had to learn painfully to help you develop our Angular applications much neater, efficient, and like a pro. So why are you here? Answer is fairly simple. It's because I have the keys for your success. And what are these keys? All right. That was a little bit of a joke. But in reality, these are probably the biggest changes that will lead you to build smarter, better applications that perform at scale. So the first one is being lazy. Second, cancel all your trial subscriptions. Cache all the things. And I don't know how many of you guys are artists, but I doubt any of you are like Picasso, so don't redraw. All right, major key alert. Our first key is to be lazy. And what do I mean when I say be lazy? Well, chances are whenever you create a new component with the Angular CLI, you run a command like this, and you are greeted with this as a result, which is normal. It's what we expect. It's no biggie. So as expected, our component has been brought into our app module. But what happens for a larger application with many components and modules from NPM that we might want to use? We get something like this, and I know it's probably kind of really hard to read, but in this application, there's maybe 4 or 5 routes, a couple of services, I think 2 pipes, and some simple libraries, I think from the Angular material component library, that's taken what was roughly 20 lines of code to over 70, which is just massive. When we go to build our application for production, we end up getting something like this. And you might be able to see the code that we have written for our components, our pipes, and whatnot takes about a meg, which, while most of it is vendor imported libraries like the router, forms, the common, Angular common, it's still a massive payload up front. And remember, we only have like 4 or 5 routes, 7 components total. What happens when we work on larger applications? Well, how many components do you end up having? Maybe 20 components, 100 components, 1,000 components. When I say be lazy, what I'm really aiming to tell you to do is minimize that initial payload such that we get our initial load faster. Not every route or group of routes needs to be loaded when a user visits our site. So if we did break up our route into individual modules, which we would have a build that looks more like this, where we have 7 chunks total rather than 4 from before. The main entry point of our application is a little bit tinier. We shaved off close to 200 kilobytes. And our 5 routes are now belong to their own related modules that will load whenever we want to route into them. This cuts down the initial payload of our application. So now when we visit our application, we see our main app that gets loaded. And when we navigate to our next route for signing in, a new chunk 1, which you might be able to see in the bottom after the click. Chunk 1 is loaded into the application, and it's only loaded when we need it. Loading in modules only when we need them to, that's lazy. So you're right to be skeptical. It's a little too good to be true. And there are 2 primary considerations that you need to take into account when you want to implement lazy loading. The first one is going to be your routing. So before we would have configured our routes onto a component by component basis. And like we saw before, we would bring in all of our components into our app module. And so we have every route gets mapped to a component here. But rather than doing this, we're going to make a few small tweaks. The first one is for every one of our main routed areas, we're going to create an app module for that route that will take care of the component loading in the component and the routes for that component. So we have the parties form, parties list, all these parties related components, and I also have imported a parties routing module. Then we're going to purge all references of our components from our app module. And we're going to load things in lazily, which not only will be a performance boost, but it'll also be more readable, like this. This is coming down from the 70 lines we had before. We had this. We have this. I think that's an improvement in readability for the entry point of our application. So now with no reference to our components inside of our app module, we're just going to have our routing point to the modules that we created, which we can see here. So if a user navigates to anything with the prefix auth, it'll load the auth module. And so the load children, it has the route to the file and the hashbang symbol and then auth module, which is the class to import from, just because you can import possibly multiple different classes or have different classes exported from that file. Then there's the modules bit. And there's a concept called shared modules and core modules. The shared module is something that you can think of as assets and resources that will be used repeatedly throughout the application. It's things that will have to have multiple instances, like components, directives, pipes, and whatnot. And the core module should exist for things that you should only have one instance of. Singleton objects, perhaps like your services. If you have a service that's dedicated for the for the user state and auth, you probably don't want to have multiple versions of those running around, just because if you call one and it gets instantiated, it might not have resolved in time with a response if it's making an API request or something like that. A great example for the shared module, though, is like if you're using the Angular material library, where you might import different components that will be reused again throughout your application, like a button, a nav bar, etc. Those would be useful cases for a shared module. But here's a quick example of this shared module that I mentioned. This is where I'm bringing in a few modules I'm going to be using across the entire application. Most of these are from the Angular material library, but I created maybe 2 or 3 of my own. There's a few pipes. And so what we do is, because these components for the Angular material library, as well as some of the pipes that I'm using, will be used across the application, I'm just going to import the shared module into every module that I will reference these components. Before, because everything was coming into the app module, dependency injection will give me access to everything across the application. Now that the app module isn't importing those, I won't have references to them, so I'm going to have to inject these into these modules. But we don't have to do anything in our app module. I'm not importing the shared module because I'm not using the shared module. The only thing the app module is doing is taking the routing and redirecting the user to different modules. So that's a lot less imports I need to bring into my app module. My app module doesn't need reference to all those Angular material components. And this is just a quick example of the core module where we brought in our singleton providers, which are our services that we're going to be able to use all over the application. And all we have to do is import the core module into the app module, just because there should only be one instance of it. If we ended up importing that into every single module, we'd have multiple instances of those services, which we don't want. All right, so first key done, next key. Canceling your trial subscriptions. Just by a show of hands, I'm sure not everyone here is an Angular developer, but how many of you are familiar with RxJS? Okay, I want to say about half of the audience. Cool. So let's discuss how we can get a little bit smarter when using RxJS. So just a few things to hit on. The first things that we're going to be using is the async pipe. The next bit is going to be the first function, and let's hit on that async pipe. So if you've used a library that returns the data, like RxJS, that returns data as observables, or even built services that return data that you need as an observable, you'd think that an easy solution to get your data that you need is just to subscribe to the data and set some variable into the component to the value. Something like this, and I'm assuming this looks good to most everyone in the room. Quick question, how many in here are actually Angular developers? Do you guys see anything wrong with this? Okay, I'm assuming that looks good. I'll leave that for a second for you guys to take in and appreciate that. Okay. In the example above, even when we leave our component, the memory allocation of our subscription will remain. On the init, we do the subscribe, but at no point do we unsubscribe. So if we keep on going back and forth between routes and this observable is being resubscribed to, the subject observable, whatever it is we're subscribing to, will have multiple callback functions that it's going to try to call and execute on. And if you just keep on doing this, at some point your browser will crash. This constant listening to changes is typically called an infinite observable, which may be useful if we're using something like Firebase and we want to update our view based on changes. But when we leave the component, we don't need to update the view. We don't need to listen to changes. So what you might end up doing is something like this. We can take our subscription, assign it to a variable, and just unsubscribe from that on the destruction of our component. And this is perfectly acceptable. But what if you forget to kill that subscription? I mean, you might have a lot of hands working on a code base, refactoring code. Things can easily slip past developers. Just by a show of hands, how many of you guys, just from having initially looked at the code where I didn't include the unsubscribe, you guys were okay with that? Which, we got one?
No, I have a question.
Yeah.
Because Angular, if you use the HTTP client, the observables give back will auto subscribe.
Yes, the observable on the HTTP client, I believe instead of calling internally in the observable, instead of calling next, I believe it calls finally. So I believe the three internal states are next, error, and finally will emit and kill the subscription, from what I recall. I haven't ripped apart RxJS in recent memory. I just trust that the code I've written works still.
Basically, it has similar mechanism with async type.
Yes. There's more to it than that, but that's just for the HTTP service. If you're writing your own stuff, or if you're getting data from a reactive data source, or using like WebSockets, that's not going to do the trick. Okay, so simple thing. What's a cleaner and simpler solution than this? Well, rather than subscribing to our observable to get the value, we can just pass the observable straight to our component, which saves us a bit of code when it comes to our lifecycle hooks. I've removed the need for two hooks, the onInit and onDestroy. I've removed two variables, the variable that I'm assigning the parties to and the subscription that I'm unsubscribing from, and I've stopped the subscribe and unsubscribe. I'm just going to give the observable to my view. And I know what you're thinking, Michael, this looks beautiful, but my observable is a data stream, and I can't just render a stream of data in my view. To which I would agree, but Angular can do that. In our view, I iterate through an array of games, and I receive that array from my observable. And I do this all with the ng-for statement. And all I have to do is just a tiny minor tweak in order to get this to work. all I added was the async pipe, which will subscribe to an observable or promise waiting for it to resolve, and it'll update the view based on newly emitted data. And when the component is destroyed, it'll automatically unsubscribe for us to avoid any potential memory leaks. This pipe is classified as an impure pipe. And pay attention to that word, it will come back later in the presentation. But thankfully, it just makes our code cleaner and handles a lot of the work for us. But sometimes you need the value of the observable inside of your components or services. And letting the Angular template handle the subscription in the view just isn't going to cut it for you. In the case of getting something like Firebase, it returns to you the user object in an observable. So what happens when you need to get something like the user's name or the user ID for a request or some other task? I don't want to keep the subscription active after I resolve my insertion of a game here, so what do I do? Well, RxJS has a slew of operators for our observables. The first one I want to show you, though, is the first operator. And all this does is it waits for a value to be emitted, and once the first value is received, it'll kill the subscription for you automatically. The next one is take n, which will emit n, however many values you want to have emitted before it'll kill the subscription of the observable for you. There's take while, where you pass in a predicate, and it'll test the emitted values against the predicate. If at any point the test returns false, it'll kill the subscription. And finally, you can take the first pipe that I mentioned before, pass in a predicate, and it'll check each value against the predicate function. If the predicate function returns true, it emits that value and completes. Cool. We got another one. Now, another strategy we can use to allow our applications to scale for performance is to use service workers to cache our application, assets, and even HTTP requests on the user's device. This ties into what makes progressive web apps so powerful and popular. Simply put, they feel ridiculously fast for our users because we save making requests to the server, which is also beneficial to you as you're able to cut down on the client hitting your server for resources which costs data. Which uses data, which costs money. So all you need to do is ng add @Angular PWA module to your project. It'll add the Angular Service Worker package to your project. It enables Service Worker build support in the CLI. It'll import and register the Service Worker into the app module so you can directly access the Service Worker throughout your Angular application. It'll update your index HTML to include a link to the manifest.json file. It'll create a default manifest.json file, and it'll add meta tags for theme colors. I think if you guys are Android users, you visit some sites, sometimes you'll notice that the address bar will change color to match the application. It'll install icon file support. It'll install icons so you can support the install of being a PWA. And it'll create a service worker configuration called ngsw-config.json, which specifies the caching behavior and other settings. The service worker can automatically prefetch and cache all static assets for an application, making it possible for your app to work even when there isn't an internet connection. And even if an internet connection is available, the app will load in more quickly because all of the assets are available in the cache. That way, next time your app loads, it'll pull from cache. It'll pull from the cache. So all you need to do for that step is just run the production build ng build prod and check your dist folder, and you'll see a file called ngsw.json. And if you look into that, you'll see all the assets that will be cached and created by your service worker. However, this doesn't include custom caching strategies or our other configurations which we need to define, which you can do this by modifying the ngsw manifest.json file in the root directory. The CLI will mash your custom logic with the auto-generated one. Easy. Cache all the things. But there's one more thing, and this is where we get into the little bit more technical deep dive. So I hope you guys are ready for this. We're going to be discussing redrawing. And if you guys are familiar with change detection on Angular, this is going to be awesome. If not, this is going to be a little bit of a crash course on how that works. So the first thing I'm going to discuss is the OnPush change detection strategy. So here we're looking at a component which has two child components for creating a party, as has a child component for creating a party as well as two party list components. Hypothetically, if we inputted or interacted with the parties form child component, change detection is triggered in our parent component, and now the parent will invoke change detection in its children, such as the two party list components, and it'll invoke a depth first traversal in the component tree. But this change isn't really necessary for those parties lists unless we have new parties that we're passing into it. So if I'm just typing into the parties form, I don't need to redraw the parties list until the user hits enter and we created a new party. So all we're going to do is update our parties list component to use OnPush change detection. And if you look over the Angular documentation, we will get this definition. So on push, when the check once strategy, meaning that automatic change detection is activated until reactivated by setting the strategy to default. Change detection can still be explicitly invoked. And the default state is to always run no matter what. So what does this mean for us, though? Well, on-push change detection will be triggered when the framework with a reference check determines if any of the inputs of a component have changed. Angular does a triple equal comparison for a new value before updating a reference check, and passing in a new reference triggers change detection. For an array, though, what we would probably need to do in order to trigger a new reference check is to copy the array, push in a new element every time we want to update that, and that's intensive. In order to copy the data of an array like data structure, we need to iterate over the original, which can be resource intensive inside of a browser. Facebook actually provides a really good library that can resolve this called Immutable.js. With Immutable.js, you'll get a new reference on change, and Immutable doesn't actually copy the entire data structure. So it's a little less data intensive for the user's device or the browser. I'm not sure if you guys or girls can see why Immutable.js is cool, but there's something here that I like because I find it very, very convenient. And that's just finding the index of a party by passing in an object instead of having to do a check. Typically, and I might be mistaken with this because I haven't done it in such a long time, I doubt myself, but the only time I can do index of is if I'm passing in a simple object or if I end up writing some fancy function. In this case, I can just pass a direct object in without having to do a check. It'll handle that for me. And so then I can splice once I find the index. So I recommend you guys looking into it. Obviously easy to use, just npm install immutable. Now, remember change detection is invoked for every element of a component when changes happen. OnPush will trigger change detection not only when new data is passed in, but also when an event inside the component happens. So going over the Angular pipes, and this will tie back in a second. There's two types of pipes that we will discuss. There's pure pipes and impure pipes. So pure pipes are based on pure functions, which is kind of a concept in functional programming. There's two properties for a pure pipe. The first one is that there's no side effects. So it shouldn't do a console log, it doesn't touch local storage, and it doesn't make any network requests. The other property of a pure function or a pure pipe is that you'll always receive the same result for the same argument. An example of this is the date or currency pipe in Angular. These pipes are only invoked when it detects a change to the inputted value. A pure change is either a change to a primitive input value, such as a string, number, boolean, or symbol, or a change object reference for like a date array function or a different object. Then we have our impure pipes. An example of an impure pipe is the async pipe, and that should be a callback for you guys. Hopefully you guys remember that. But an impure pipe is a pipe that will hold a state internally, like how it holds a reference to a promise or an observable. So a needlessly complicated computation is Fibonacci. If we were hypothetically iterating over 1,000 entries in a component and calculating their value in a Fibonacci sequence, well, we're going to end up killing resources. As I mentioned before, though, the OnPush will trigger change detection when an event inside of the component happens. So when we type anything inside of this input element, the Fibonacci function will fire again for every element in our array. So we can fix this by moving out the Fibonacci function into its own pipe. As a pure pipe, unless the input changes, then the pipe isn't going to run. And so now when we type anything into the input element, our Fibonacci pipe will not fire again because the count value hasn't changed. Because the same input will always be returned the same output, we also don't need to recompute the value for every input. In computing, and I'm going to butcher the pronunciation of this, but memoization is an optimization technique used primarily to speed up computer programs by storing the result of expensive function calls and returning the cache result. I don't know how many of you guys have had to do the Fibonacci problem as a whiteboard question and then asked to make it better. Yeah, this is the technique. Cache the result, check cache. If it's not there, move on. So a great tool to easily implement memoization is Memo Decorator. It's maintained by, he was an Angular GDE, Minko, I'm going to butcher his last name, Getchev, but I actually think he rejoined the Angular team maybe 2 or 3 weeks ago. So if you're using TypeScript, you can apply the Memo Decorator. All you have to do is really just import the Memo Decorator and decorate your transform function with it. Now your inputs will be checked against the cache and they'll return from the cache instead. So I'm sorry if this was a long talk. I offered to you all a potato. Just if you guys are interested in learning more, I have a few references that I'll leave this up if you want to take a screenshot. The first one is the Angular Style Guide, which discusses the concepts of the core module, the core module, shared module, as well as the lazy loading and a lot of those concepts about how you structure your application. The second one is, it's a kind of old article by Ben Lesh. If you guys aren't familiar, Ben Lesh is the lead maintainer of RxJS. He's also a member of the Angular team. I recommend looking at that. While some of the syntax is a little outdated, the concepts discussed are still applicable. The third item is also going back to the Angular docs about implementing the service worker and building PWAs, which I recommend you taking a look into. And the final one is a talk from ngconf by Minko about a lot of these last performance things that I discussed. So I invite you guys to look over all of those content. If you want to be able to look over these slides, here's the URL, short bit.ly/Angular keys. I'll keep this up for a second if you guys want to take a pic. And while you do that, I'm going to take a sip of coffee. All right, so remember, you're smart. You're very smart. You're the best. You're a genius. Thank you for your time, everyone. My name was Michael Slotty. You can find me on the web, all these places, and I am now open to questions, comments, concerns, criticism, and most importantly, praise. Thank you.